the other useful thing we learn in this problem. Suppose velocity has been given as a function of displacement. Let's see, v is equal to 3s square minus 2s. Suppose this kind of function we have, and we have been asked acceleration at any given displacement. For example, at acceleration at displacement 2 unit. Now, how do we do this? Acceleration is dv by dt. We know this. Acceleration is rate of change of velocity. Change in velocity upon change in time. This formula we have seen before. Now, here we don't have velocity as a function of time. We have velocity as a function of displacement. So this as such is not going to be used straight away. So we somehow we have to get the differential in terms of displacement, because we have velocity in terms of displacement. So getting motivation from there, I will multiply and divide dv by dt with ds, because ds and ds can be cancelled, but we learned in the previous problem. So this is effectively 1, so no problem multiplying it by 1, and then I will club this dv by this ds and this ds by this dt. So what we get is dv by ds into ds by dt. Now dv by ds is straightforward to find from here, because we have v as a function of s. So dv by ds can be straight away found by the formula that we studied before. And ds by dt, change in displacement upon change in time, is actually velocity. So this effectively is velocity into dv by ds. Fine. Now velocity at any displacement is known by this equation directly. So velocity at displacement is equal to 2 can be found just by putting s is equal to 2 here. When we put s is equal to 2, it's 3 times 4, 12 minus 4, that is 8. So velocity is 8 when displacement is 2. And dv by ds can be found out. dv by ds will be equal to 6 into s minus 2. This is a polynomial differentiation that we have studied before. It shouldn't be a problem for you at this stage to find out dv by ds. dv by ds will be 6s minus 2. Now at s is equal to 2, dv by ds is equal to 10. Fine. So acceleration at s is equal to 2 can be found out by putting v and dv by ds. V we have found out as 8 and dv by ds as 10. That turns out to be 80. So this is how you actually, this is mathematics, this is manipulation. There's no physics in this. And the manipulation, the kind of manipulation that you have done before, the kind of arithmetic that we are familiar with, that will hold true in this case, as long as it is the first differential. And this one is an important problem. I mean, it would be a good idea for you to try it all over again, the same problem, without looking at the solution, because your mind should be trained to think in this direction, how to get it done. It's still very simple. In exercises that you will be solving, I'll add on few little bit of complicated problems so that you have more opportunity to learn this. Now I've been saying for a few minutes first differential. I'll tell you what first differential and second differential is. If I have y is equal to x squared, if I want to differentiate y with respect to x, I get 2x. Okay. Now I differentiated y with respect to x for the first time. I got this. This is also represented as y dash. So y dash is 2x. Now if I go to do the same thing all over again, I'm going to differentiate whatever I get with respect to x again. I'm going to do it again. Then actually we represent it as d square y by dx square. D square y by dx square means y has been differentiated with respect to x. Now whatever you get, you differentiate that with respect to x once again. So when you differentiate y with respect to x, you get 2x. Now you're going to differentiate 2x with respect to x once again. When we differentiate 2x, we get 2. So d square y by dx square is 2. Now this is called second differential of y with respect to x. This is the first differential of y with respect to x. When you differentiate it for the first time, it is dy by dx. When we go on differentiating it for the second time, it is d square y by dx square. If we go on doing it for the third time, that will be d cube y by dx cube. This will be called as third differential. Now the important thing for you to note here is the arithmetic, the normal arithmetic, that is not true for the second or the higher order differentials. Now d cube y by dx cube into dx cube by dy cube is not equal to 1. You cannot cancel out this just like that, just as you do with normal numbers. It is not true. This is wrong. We cannot do the normal arithmetic operation with higher order differentials. Not for second, not for third, not for any other higher. That could be done only and only for the first order differential. That is allowed. I mean, the result holds true. That's why we do it. We can do it because it does not hamper the result. The final result anyway is going to come right even if we cancel it. So it is allowed. You can do it. But for the second order differential, third order differential, for higher order differentials, we cannot do that. So that cutting dy by dx with dx by dy, that cancellation we should not and we will not do for second order and higher order differentials. That is only done for first order differential. Okay. Now, just to add here, if displacement is given as a function of time, calculating velocity is easy. Velocity is ds by dt. Fine. Now acceleration is dv by dt. V actually is ds by dt. So acceleration is differential of v with respect to t. That means differential of ds by dt with respect to t, because v is ds by dt. Now this means you are differentiating s with respect to t first. Whatever you are getting, you are again differentiating that with respect to time for the second time. So this effectively is d square s by dt square. That's the representation. This is how we represent it. This is symbol for differentiation of s with respect to t. Whatever you get out of it, you again differentiate that with respect to t. Now that kind of operation is represented as d square s by dt square. Now that is acceleration. So the first differential of displacement with respect to time is velocity. The second differential of displacement with respect to time is acceleration. You should take a note of that. Now we'll stop doing problems. Now what you have to do here is you go to exercise 1. You solve exercise 1 on Kinematics from our website. You download it and you spend some quality time in understanding those problems and solving it on your own before you take any leap forward. Because if you don't get things under your belt and you just move on and on, actually you're not gathering anything. You will not understand, you will not develop an aptitude how to approach a new kind of problem. So at the end you will study a lot, you'll not be able to solve a new problem in exam or for any situation for that matter. So spend some good amount of time in solving exercise 1.